Good day. My name is Ian Land, and I'm the Senior Director of Aerospace and Government at Synopsys. And I am meeting today with Dr. Johannes Stahl, who's our Senior Product Marketing Director in our System Design Solutions Group, and Dale Donchin, our Senior Program Manager, who's also in our Aerospace and Government vertical. Both are also employees at Synopsys. Our topic today is to learn about analog mixed signal emulation technology and the challenges, results, and impact of the DARPA POSH program. We're going to start off with Johannes. Johannes, I have a question for you, just a simple one. What is AMS simulation technology?
Thanks, Ian. So semiconductor devices are typically digital or analog or a combination of the two. And we refer to that as AMS for analog mixed signal. So if you look at emulation, it's the ability to test the circuit prior to production on a specialized hardware platform called an emulator. So this is a very critical step before you tape out, so you know that your design is bug-free before you produce it. Historically, suppliers like Synopsys had emulators that were capable of doing digital emulation. Now in the DARPA program, we have worked together with DARPA and others to curate technology to do that also for AMS circuits. So this is a one-of-a-kind new technology.
Very good. Now let's switch over to Dale. And Dale, what motivated DARPA to develop and sponsor this initiative?
Thanks, Ian. Well, DARPA is investing to improve the design and verification of semiconductors, as well as the speed of EDA innovation. As Johannes mentioned, AMS emulation is one of those opportunity areas due to the increasing complexity of semiconductor designs that often include the combination of analog and digital circuits.
Okay, and what was Synopsys' role in this program, Dale?
Well, Synopsys took on the challenge of high-speed AMS system verification performance, which has been falling behind advancements that we've observed generally in Moore's Law. The industry norm of using SPICE was unable to keep pace against increasingly more complex circuits, and it couldn't provide sufficient capacity for system-level designs and lacked the ability to co-simulate with system software. A completely different approach was necessary. Synopsys worked to build virtual models of semiconductor chips that enabled AMS verification prior to silicon tape-out.
Okay, and why is this emulation technology important to aerospace and defense?
Well, the A&D community suffers some significant costs and schedule overruns when design flaws are detected post-silicon manufacturing. However, until now, it was very difficult, if not impossible, to verify pre-silicon a complete system encompassing AMS content like DDR and SerDes physical interfaces, digital processors, and firmware that's required to calibrate, tune, or equalize the high-speed analog circuits with real-world varying phenomena such as PCB impedance.
Got it. Okay, thank you. Now switching over to Johannes. Johannes, how did Synopsys overcome the challenge of pre-silicon verification for AMS designs?
Yeah, thanks. So on an emulator today, you were emulating standard models written typically in System Verilog. And what we did here, we extended that capability to include System Verilog real number models, RNM, for capturing the analog circuit behavior and the interfaces to the digital logic. So this was actually already used in simulation, but the execution speed in simulation for these descriptions was really insufficient. So real number models support floating point signal values common in analog designs using mathematical equations to express the circuit behavior with a high degree of fidelity, which is important. Resolution functions describe the conversion between analog and digital domains, and the real number models are generic, enabling use for a wide range of AMS designs, which is important, both as inputs and outputs from digital-based subsystems. Using such a well-established and well-documented hardware description language was our preferred approach over proposing yet another new syntax. Synopsys enhanced this emulation technology to enable this AMS emulation as part of our high-performance emulation architecture. RNM models can now be mapped as part of emulation.
Excellent. That's very good. Exciting stuff. What results did users achieve, Johannes?
One of the interesting examples is the verification of a system using DDR memory. Of course, this is a commonplace in many SoC designs. So the system driver must perform a complex series of operations. The firmware is driving this to train the system setup for the sweet spot, where the best signal-to-noise ratio for the analog eye diagram is reached. A performance increase of 200 times for this emulation solution of the firmware behavior compared to using simulation was observed. This is, of course, critical for the end user. Now, the entire system, including the DDR controller, the PHY, the memory models, the processors inside executing the firmware, and the calibration firmware can be verified pre-silicon, and this greatly reduces the system integration risk and also deployment time after silicon comes back.
Okay, very logical, very good. Now, if we look more broadly, how can this accomplishment be utilized in a broader market?
Well, from a broader market trend perspective, the biggest trend we are seeing today is the advent of multi-die system. Multi-die system integration is a tidal change in the way the semiconductor industry needs to approach also the system validation. Tasks that could traditionally happen later at the board level post-silicon, now they have to move to pre-silicon. We expect that many design teams will enhance their verification methods to include AMS emulation to verify the many die-to-die interconnects pre-silicon.
Okay, very good. And now finally switching back to Dale. Dale, what's next for aerospace and defense with this technology?
But pre-silicon system level validation of DDR IP is really only one instance that benefits from AMS emulation. Similarly, complex AMS design like PCIe, power conditioners, filters, converters, and many types of sensors can be verified in system context using this AMS emulation technology.
Very good. And that's really what we had for today. To wrap up, I first want to thank Johannes and Dale for this exciting discussion on AMS emulation. Please stay tuned as we take this technology to market in 2023. I would also like to thank you, our audience, for your time and interest. And this is now a very, we've had many newsletters, and it's been very good. We're thrilled to have the interest that we've seen across our audience. And then finally, I invite you to visit the Aerospace and Government Solutions webpage at Synopsys and sign up for this quarterly aerospace and defense newsletter. Thank you very much, and we'll see you next time.